Hello, everyone. Welcome to the Firebolt SQL Clinic live stream. We've got a pretty exciting topic here today. I'm joined by Connor and Guy, who are going to be going over SQL, Firebolt, how to improve your queries, optimize your queries, make Firebolt run a little better. Whether you're joining us on LinkedIn Live, on YouTube Live, you can pop questions in the chat for them if you have anything you want to learn about, and we'll pull that up on screen and have them address your concerns. With that said, I'm going to get out of the way, let them run the show. They'll introduce themselves and give a little more detail about what we're talking about today, and hopefully the questions can start rolling in.
Thanks, Cole. So hello, everyone. I'm Guy. I'm part of the customer success team here at Firebolt. And we have Connor.
Yeah, and I'm Connor. I'm a solutions architect at Firebolt. So I pretty much work day in, day out with our customers, help them get successful with Firebolt, help them achieve their goals with the product. Guy and I have both been in data for quite some time. For me, over 10 years in the industry. I think Guy a little bit longer than that.
Yeah, pretty much.
But yeah, we have a lot of fun with Firebolt and with SQL.
So what we're going to do today is actually getting questions from you guys and then discussing them a little bit and hopefully giving you some practical answers you can go and use in your own code and scripts. So yeah, we actually have a first question here. So let me read it out loud. Hi, Firebolt. I've seen a lot of reference around primary indexes as one of the main ways to optimize queries. Can you explain a little bit more about this subject and maybe show an example on how to select the right ones? Okay, that's a really common question, to be honest. So yeah, Connor, what do you think? How should we approach that?
Yeah, so if you guys have read a little bit about Firebolt, you've seen indexes all over our marketing and our documentation. And yeah, as this viewer said, it is one of the main ways to improve performance. The reason for that is because indexes in Firebolt are a form of sparse columnar index. So what that means is that you can have multiple columns specified in your index, and that controls how data is grouped and sorted on disk. So if you're used to like a regular primary index in a system like MySQL or Postgres, those indexes are really good at finding individual rows. So if you're doing like point lookup queries, it allows you to very quickly say, okay, here's this exact like transaction ID. What the sparse columnar indexes in Firebolt allow you to do is quickly identify groups of rows. And so when you're doing analytical queries, for example, like a filter or a aggregation or the common types of queries that you might encounter for your reporting application, it makes it a lot faster to find the subsets of potentially a very large data set that you're looking for. So Guy, I mean, I can show an example if we want.
Yeah, let's do that. Definitely.
Right. Let me pull that up. All right. Cole, can you, there we go. Perfect. I like having our little background Cole to make things work well on the screen. So what we've got here, this is one of our sample data sets. If you guys have Firebolt, you can actually pull up this data set yourself and bring it into the application to work with. It's just this, it's our example data set. I'll quickly show you how to get to it. You go into load data, and then you just use Firebolt Playground Bucket to load sample data. And this is exactly what we're working with. So this data set that I've brought in, this is a single table called PlayStats, and it's actually got about 1 billion rows, and uncompressed, this is 150 gigabytes. So pretty typical large scale data. You can see here as well, or you can imagine that if I want to have a query that runs across a lot of this data in a traditional system, this could take some time to process. because you've got to find the exact time period that we're looking for, the exact player IDs, the selected cars, and then do some aggregations. What we've actually set up on this table are 3 primary indexes. So in order, those are stat time, player ID, and selected car. And those are going to allow us to really easily identify the chunks of records associated with these different categories. So the impact that that has on our data set is if I go ahead and run this query, and this query is executing cold. So that means we don't have any data in cache. We're not pulling from like a result cache or anything like that. But you can see that completes in about 1.8 seconds, and it scans just a very small subset of that data set. I can adjust the time ranges. So maybe in this case, I want to look at like a year of data instead of just a single month. And once again, super fast. We're scanning 5 gigabytes this time, but returning the results in 0.99 seconds. So it's a little bit faster because we've actually moved data from remote storage into SSD and are able to query that. But indexes, main way to reduce the amount of data that a single query scans and allow you to get results more quickly.
Oh, Connor, here we have 3 filters, right? We have selected car, we have player ID, and we have the time.
Mhm.
What would you say, like, is there a fixed number of primary indexes that you would say that above that, the query would be less performant, or we would expect kind of the data scan to be larger than what we would want it to be?
Yeah, so the order of the indexes does matter that you specify in your create table statement, because again, that determines how the data is being sorted. So when we're building our tablets, that's what we call these subsets of data on inside of Firebolt. We start with stat time, and then under stat time, so maybe we've got like one value for November 1st, 2022. And then under that, we have, okay, for November 1st, you have player ID 999. And then we have Inferno. So you end up with sort of this set of chunks. So the stat time, the player ID, and then under that, the selected car. So you can imagine if you index every single column in your table, you certainly could, but you're essentially ending up with just rebuilding your table. There's no long runs of data that Firebolt can scan over to give you faster performance. So the amount of columns that you add into your index can be very subjective, like based on what your query patterns are. Most of our customers use, up to 10 or 12, because that tends to give a good balance of covering a large percentage of query patterns, but also not getting so granular that you've really just got one tablet per row, in which case, like, why have you bothered? You have a table again.
That makes a lot of sense. So I see Cole ask a question actually. So how can I process JSON data in Firebolt? Yeah, that's a good question.
I love this question. This question is also sort of close to my heart because a lot of people at Firebolt know this, but I had a side project that I did a couple months ago to build my own app using Firebolt as the backend for ski racing data. And so all of that data is actually JSON. Firebolt is super powerful on JSON, and a lot of other data warehouses and databases have JSON parsing functionality as well. But I'll share my screen again because this example is quite good for JSON data. So this is from my ski racing results app. The data that we ingest in comes in JSON format. You can see an example of that format here. And it tells you for every racer what exactly their times are and how they're performing. And if I look at I'll bring over a prettified version of this table. This is the raw file that you can see here. So you can see inside of this JSON, let me go all the way to the top. This is a really big JSON.
A lovely one.
Very lovely JSON. You can see that there's sort of nested values. So we have both objects, key values, and then inside objects, we have arrays. So here's an example of an array with the actual time data. And so jumping back into Firebolt, the way that you can pluck information out of both the object, so those key values, and the more deeply nested arrays is through using JSON functions. So the first one we have here is JSON pointer extract. So you pass in the path that you're looking for, and that's going to pluck the value associated with that JSON path out. Now, you might remember from that gnarly JSON that I was showing that we have this MA ranked field that is actually an array of other values. And so when we're working with that type of data, you can use a different function. This one is called JSON pointer extract array. And what that's going to do is just identify, hey, this pointer is not just a string value. This pointer is an array of other objects. And of course, when you have an array, you can then unnest or unfold the array. And so that's what our unnest function does. So what we ultimately end up with here, let me run this guy for you, is going from that JSON formatted data that we have in our raw table, this full results table, and ending up parsing that into rows and columns. So this ends up being much more human readable, and you can then go and do other operations on top of it. So the full pipeline here for this particular project is ingest the raw JSON from the timing file, extract it into an intermediate table, and then do additional processing on top, because we care about things like aggregated times and rankings and all of that good stuff.
That's perfect. So in terms of process, you bring into Firebolt the nested kind of the JSON table.
Mhm.
And then do you insert the data again? Like, do you transform it and then create a different table afterwards?
Yeah, that's exactly the process for this. I wanted to do all of the operations on the data warehouse instead of relying on, say, the files or doing an external ETL process, just because from my experience, it's a lot faster and it's a lot easier to orchestrate inside of Firebolt. So that raw JSON file lives on S3. And in Firebolt, we have a concept called an external table. So it's essentially just a pointer to the file location on S3. And you can query that data directly from Firebolt. It just doesn't tend to be as fast as like a native Firebolt table, because it's more of a federated query style instead of us managing the storage. But I use that external table as my like raw data zone or landing zone, and then ingest the data into Firebolt. That's the first step, going from that JSON, plucking out all the different fields and creating my temporary table. I then have an additional table that I create after that that does a little bit of normalization. I do some lookups against dimension tables to figure out things like people's class, the team that they're a part of, and then aggregate on top of that. So
Got it.
pretty standard, like multi-step, like raw data, refined data, like final table.
Yep. Okay, so I know we're called the SQL Clinic, but actually the next question is around our engines. So
Okay.
I'm used to increasing compute size from small to medium to large. So yeah, well, different competitors of ours are using that. So I'm not sure about the concept of nodes and clusters and how do they fit in. Right. So yeah, we have elasticity. We can both scale up, scale down, and scale out and scale in. And so maybe Connor, let's maybe talk a little bit about when would you want to increase your engine size or decrease it, and what method would you use in that case?
Yeah, sure. So like Guy was saying, the engines in Firebolt, they're a little bit different than engines or warehouses in other cloud data warehouses. Really overused that word warehouse there, because there's 3 different ways that you can resize. So it gives you a lot of flexibility. The first, if we go down to the smallest unit of an engine, you have an individual, I'm gonna call it like a server or an EC2 instance behind the scenes. And so that can be of a different size. So you can have small, medium, large, extra large. Each of those is a different EC2 instance behind the scenes, and it has a different amount of CPU, RAM, and SSD attached to it. So the first unit of scale is simply by going from one size machine to a slightly larger machine. The other way that you can scale, so now instead of looking at a single machine, is you're looking at a group of machines. So this is adding nodes. We're calling each of these machines a single node. So you can have a 2-node engine that has 2 of the same size machine, or you could have a 3-node, 4-node, what have you. So adding nodes lets you distribute your processing. So it can be really good for ingestion if you're bringing in a lot of files at once. Super easy to parallelize by just adding additional nodes into your engine, and that lets you process multiple files in parallel. It also can work for maybe you have queries with kind of complex processing needs, where you can actually benefit from distributing things like aggregations or joins across multiple nodes. The third way that you can scale is by adding a cluster. So we've got our node of type small, and maybe we've scaled that out, so we have 2 nodes of type small. But you've got, let's imagine, like 1,000 users all querying your database at the same time. So you're now encountering a potential concurrency bottleneck. And adding a cluster allows you to scale for concurrency. So you take that 2-node small engine and you say, instead of having 1 cluster, let's have 2. So now you have 2 independent 2-node smalls behind a single endpoint. And Firebolt will distribute the incoming queries to either one of those 2 clusters to sort of balance the load.
Yeah, and just to add to that, you kind of talked about the technical aspects of our elasticity abilities. We also have kind of in terms of cost and efficiency, with other competitors, in some cases, you can only scale up, right? So you would go from that small to medium to large. But with Firebolt, in a lot of cases, you might prefer going from 1 small to 2 smalls, like 2 nodes of a small engine, instead of needing to kind of double your costs just to get a little bit of an edge in order to do whatever you were trying to do.
Yeah.
Connor, maybe we can show kind of in the UI, how does it look like, and just show the pricing differences, for example, between moving from small to medium over and compared to kind of going from 1 small to 2 small.
Yeah, I'm happy to. Let me share my screen one more time. But before we do that, it looks like we've got one more technical question here.
Yeah. So does adding a new 2-node cluster work differently than just adding 2 more nodes?
Yes, absolutely. So the difference here is that clusters, again, are for concurrency. And those two clusters are completely independent. So queries don't have access to if a query is running on cluster 1, it can't access any of the resources from cluster 2. So essentially, when you have a 2-node cluster, you still just have 2 nodes that your queries can take advantage of. On the other hand, if you stick with a single cluster and you just throw 2 more nodes into that cluster, you now have 4 nodes to work with. So any query can distribute its processing across all 4 nodes instead of being limited to just 2 from one cluster or 2 from the other.
That makes sense. Yeah. So yeah, maybe show how does it look like in Firebolt.
Sure. All right. So right here on my screen, you can see this is the engine configuration. So if I start with, we'll do a small to begin. You can see that I'll start with a small with 1 node and 1 cluster. And that's 8 FBU. And Guy, I always forget what the dollar equivalencies here are, but an FBU is how many?
35 cents.
35 cents. So this is like $2.
Yeah.
And so everything here, it scales linearly. So if I add in a second node, we're now looking at $4 per hour. If I add another cluster, that's going 2 times 2. I've now got 32 FBUs, so I believe $16 an hour. I can bring that down again, go to medium, approximately doubling the cost. But the important thing here is that you're not limited to just double, double, double. Like I could, instead of going from a small 2 to a medium, I could do 3 smalls. So you have a lot more granular control over price performance. And you can very specifically match exactly the performance that you need with the engine to your kind of requirements from a spending point of view.
Yep. Okay, so let's see. Next question. Could you please compare primary indexes to secondary indexes? When to use what? When should I use each? So, okay, we've talked about primary indexes. I think that was pretty clear. Let's maybe talk about aggregating indexes.
Yeah. So I think the question asked about secondary indexes.
Yeah, that's right. Yeah.
Which, to be fair, isn't a concept that exists yet in Firebolt. I say yet because I know it's under development. But the additional type of index that we have is called an aggregating index. So the query that I showed earlier was an aggregated query, but all that query was using was a primary index. So that initial set of kind of sorted and grouped tablets on disk. The aggregating index is a specialized form of index specifically targeted at queries with aggregations in them. So you could imagine, maybe we've got a lot of queries coming from a dashboard that are doing things like, summing up spend per client or per country. And if you've got dozens of terabytes of data, that type of aggregation, even with primary indexes, could potentially be pretty time consuming or resource intensive. So an aggregating index creates an index that behaves somewhat like a materialized view, but it's automatically maintained. So you specify these are the columns that are being used in the group by field. These are the aggregations that you want to apply on top of it. And Firebolt will maintain that separate object to accelerate any queries that might have that type of aggregation in it. The cool thing here is that once those aggregating indexes are created, you don't need to maintain them yourself. So whenever new data is ingested into Firebolt, indexes are also automatically updated. And then whenever a query comes through, Firebolt's query planner will automatically decide, oh, hey, there's an aggregating index that is going to help this query. Let's base the query on the index instead of on the base table.
So we also have a question from Jonathan around, aggregating index. It's not, they're not seem to be powerful. They are powerful. Is there a downside to adding a ton of them to every table?
Yeah, great question. So as I said, indexes they're updated every time you ingest new data into a table. And so there can be a trade-off between the number of indexes that you have on your table and the amount of time it takes to ingest your data. That said, I don't want to scare anyone away from adding a lot of indexes because, matching aggregating indexes to common query patterns is absolutely a best practice in Firebolt. But there can be a little bit of a balancing act. Like having 100 aggregating indexes on one table is going to have an impact on how long it will take to add new data into that table, because each of those 100 aggregating indexes is also getting updated at that time. I would say in general, 100 aggregating indexes on a table is probably not a best practice. But a lot of our customers have, 5, 10, 12 indexes. But again, you sort of have to decide for yourself, like what is more important to you as an architect. Do you want to ensure that every possible query against a table is as fast as humanly possible, even if that adds time onto your ingestion? Or do you want to always have like the fastest ingestion possible, but have your end users have a little slower experience? Most people fall somewhere in the middle.
I think that one of the things that are really cool with aggregating is the fact that you can include really complex aggregations within that index.
Yeah.
So you're not just limited to, I don't know, a sum or an average or a median. You can really kind of take a sum of a case when and put it in the aggregating index. So even for a more complex stuff, you would be able to accelerate your performance with just using that function. So yeah.
Yeah. We've also had customers jam like array operations into their aggregating indexes as well, which can be a super cool way to get additional performance out of more complex data structures.
Definitely. Okay, so we're almost at time, I think. I think that was really fun, right, Connor?
Yeah. Well, Guy, I always love chatting with you.
Yeah.
Yeah.
For sure. We will continue chatting even after the live stream. So yeah. So first of all, again, thank you, Connor. I think it was great, and thank you for the elaborated explanations around everything around primary indexes, aggregating indexes, engines, and JSON. And thank you for showing us your lovely JSON JSON file.
I think people in Firebolt are going to get tired of hearing about that side project soon.
I love it. It's one of my favorite accounts. Your ski project. So yeah. Okay. So thank you everyone for joining us, and hopefully next time we'll talk and elaborate more about things that are not just indexes.
Yes.
And yeah. See you next time here in the SQL Clinic.
Yep. Bye, everybody.